Hello SL2. Tonight's topic is 1.2 Simplifying Rational Expressions. I wanted to add a note this year just to make sure everyone was on the same page for rational expressions. And remember, a rational expression is just a fraction. You're going to use all your knowledge of fractions that you've built up over the years to help you solve and simplify rational expressions. So an example could be just 1 over x divided by 1 over y, or it could be anything, or another rational expression could be x squared over x squared plus 2. So there's two examples. And remember, a few things with fractions is the only time you can simplify the factors is if they are factors, not terms. So see problem number 2 here. We have x squared divided by x squared plus 2. So we cannot simplify these x squares because this is not being multiplied here. So this problem number 2 is as simple as it gets. Now it'll be different with problem 3 if we had x squared divided by x times x plus 2. Here we can cancel an x because we have x squared is x times x, and we have an x times x plus 2. So we can cancel one of these x's out with this x, and we'll be left with x over x plus 2. And again, these are terms, so this x cannot cancel with that x. So this is the simplified answer. Okay, want to just do one problem, complex fraction, and with two different methods. One method would be to look for the least common denominator and simplify it. So in this, there's 4 fractions here. Well, if we count 1 over 1, we cannot leave this with fractions being divided by fractions because that's one of our rules of simplifying. We must have no factors in common, and we have to simplify all the way down to one fraction. So method 1 would be to first look at the least common denominator. If we had to add all of these fractions, what would we use? And this is a method a lot of teachers in Algebra 1 call clearing the fractions. So what would you use what would be your least common denominator of all these fractions if you had to add them? That's right, it would be x times y. And now that is what we're going to use to clear all our fractions. So if I take xy to multiply by the numerator, I also have to multiply that by the denominator. And each item has to be multiplied by that. So if we have x times y times 1 over x, it would result in y because we would cancel out that x and that x. And then x times y times x over y would simplify to x squared. And then the denominator, x times y times 1 over y, these y's would cancel and be left with x times 1. And then x times y times 1 would be xy. So we now look for common factors, and we would put in alphabetical order. And there is a common factor of x here that we could factor out, but it can't simplify with anything in the numerator. So we're as simplified as we can get. So method 1 appears to be the fastest so far. Method 2, taking the same problem, would be to add the numerators and also add the denominators, and then look to simplify. So if we think about the numerator, if we had to add these two fractions, what would be the common denominator? That's right, it would be xy again. So if that's our common denominator, then this fraction would need to be multiplied by a y divided by y, because it has to be multiplied 1. And this fraction would be multiplied by x over x. So that would result in y over xy plus x squared, because x times x is x squared, over xy. Now for the denominator, our least common denominator would be y, and so the 1 would have to be multiplied by y over y, and that would have 1 over y plus y over y. Now we're going to go ahead and add our numerator, and we would have y plus x squared over xy, and add our denominator. So they have the same common denominator, so we're going to add the numerators. So that'd be 1 plus y over y. And now we have a fraction being divided by another fraction. So remember from class, if we had a fraction like 1 over x being divided by x squared, remember when you have fractions, you can rewrite this divide like our divide. So 1 over x being divided by x squared. And then remember, when you're dividing fractions, you multiply by the reciprocal, the second one. So it's 1 over x times 1 over x squared. And then that would answer result in multiplying across, so it would be 1 over x cubed. So always go back to a simpler fraction problem if you need to, and you can always use numbers if that helps too. So in this problem, we're going to have y plus x squared over xy divided by 1 plus y divided by y. So we'll change, our next step is to multiply by the reciprocal. This first fraction stays the same. We change the divide to a multiply, and we will change this reciprocal. So it would be y over 1 plus y. Now we're multiplying here, and before you go to multiply with fractions, try to see if anything you can cancel. I don't see anything common here or in here, but if you look at the y here, there's a common factor in y and the bottom, because we can always put this across as one fraction. So it would be y times x squared plus y over xy times 1 plus y. And then you can easily see how you could cancel this y with the y in the denominator. Okay. So here our final answer would be x squared plus y, and we can multiply that x through, or we could leave it in the factored form. So two different methods to get the same answer. Sometimes it's faster definitely to clear the fractions, but this method 2 was a good one to use to help review a lot of our knowledge for simplifying rationals. Okay, hope you have a good night. Remember to study for the quiz on trig, what we practice in class, and trig functions. And then we'll be practicing these rational expressions in class tomorrow after the quiz. Have a great night.